Frame analysis. Video 10. Steel design according to first order theory, part 4. We must also adjust the column number 5. A check shows that there are problems with maximum stress and flexural buckling with respect to the stiff direction, meaning in the frame plane, and flexural torsional buckling in the weak direction, meaning out of the frame plane. In the capacity window, it's shown that the buckling length in both directions is 5 meters, and the reduction factor with respect to flexural buckling in the stiff direction is 0.731, and the axial force capacity 1,396 kN. In the weak direction, the case is pure flexural buckling and torsional buckling apply, and in this case flexural buckling is decisive with a reduction factor of 0.383 and axial force capacity 732 kN. We test with a single lateral support for both flanges at the column's midpoint at 2.5 meters. Graphically, this is indicated with a marker at the current point. Then we perform a new design, and the capacity window shows that the buckling length out of the frame plane now is 2.5 meters and the reduction factor 0.751 with associated capacity 1,435 kN. Buckling length and capacity in the frame plane is of course unchanged. A check shows that the flexural torsional buckling out of the frame plane now is okay. However, we still have problems with the maximum stress and the flexural buckling check in the frame plane. Defining lateral support has of course no effect on these checks. Instead we have to change the section. We examine which profile is required and see that an HEA 220 is not enough, but a HEA 240 is sufficient. So we create an HEA 240. Since all columns belong to section group 2, all columns will change if we link a new section to this group, which is not desired. We therefore remove member 5 from the group by defining 0 in the group window, and then link the new section only to member 5. We then make a new analysis and a new design. And now the capacity is sufficient also for member 5. The utilization table shows that member 5 has the highest utilization with approximately 97%, and of course it's up to the user to decide which margin that is appropriate for each individual project. In summary, it's a question of trial and error until the capacity is sufficient for the entire frame, and of course, at the same time taking into account the practical aspects of the execution. But it goes without saying that the more adequate the initial choices are, the faster one reaches the goal. We have now made a design with respect to a first order analysis, and we will go on with regard to a second order analysis.